First thing you do is you find the normal and plane direction. So remember how I told you how to find the normal direction. So there you go. The book calls it line of impact, but it's a normal direction. You apply your momentum to both the A and B along the line of the normal direction. So let's do that. All right. So if you take A and B together, there's no impulse. So that's 0, and that equals the change in momentum along the line of impact or along the normal direction. So what we'll do is we'll say, all right, after the collision, I have a mass of A. I have a speed of A in the normal direction. I'm going to write that as in. And I don't know which way he's going. I'm going to call this direction positive. So I think he's going to go in the positive. Then I have B is probably moving, so mass of B times the speed of B in the normal direction. I don't know what he's doing afterwards, so I think he's going in the positive as well. Minus the momentum before the collision, that'll be mass of A times the speed of A in the normal direction. Okay, so let's try and figure out what that is. So here's your normal line. It's at a 345, and this velocity is going this direction, and it's 10. What I want to find out is what is the velocity right here. How much is that guy? So let's see. Okay, so I really don't like these 3, 4, 5 triangles. So here's what I'm going to do. I'm going to say that this angle right here is theta. The tangent of theta is equal to opposite over adjacent. So that's 4/3. This angle, if that's theta, this is also theta. Okay, so I'm going to use the angle instead of this 3, 4, 5 business. Okay, so I'm looking for this wiggle black part right here. So that's going to be 10 times the cosine of the angle theta. All right. So let's put that in up here. So before the collision, then I have a momentum of mass A times 10 cosine of theta. Which way is he going? He's going in the negative direction, so that would be a negative. And then I say plus. Now I have to do the same thing for mass B. So it'd be mass B times, let's get his value. Okay, so there's the normal line. This guy is 8 right there. This is a 3, 4, 5. Right, so this angle right there is theta, and so I'm dropping that guy back there. I'm looking for this piece right here. So that would be 8 times the cosine of the angle theta, and he's headed in the positive direction, so that's why he's plus. Okay, so how many unknowns do I have? I don't know what he's doing afterwards. I don't know what A is doing afterwards, but everything else is known because I got masses, etc. Okay. All right, now that gets me the normal direction. Now, if I want the plane direction, what I'll do is I'll take A all by itself, because the free body diagram of A, if you took A all by itself, there's the normal line right here, line of impact, and there's this big force right here. But what's happening in this direction? Nothing. So in that direction, I can apply just for mass A. I can say there's no big force in the plane direction, and that equals final momentum of A in the red direction and minus the initial. Okay, so that would be mass of A times the speed of A in the, I'll call it P for plane. Which way is he going? Okay, well, I'm going to call this guy right here, this is going to be the plus direction. Okay, I don't know what he's doing, so I'm going to say, well, I think he's going to go in the positive after they hit. Minus the mass of A times the speed in the plane direction before the collision. Okay, well that's this piece right here. So that's going to be 10. Let's see, I'm going to put it in parentheses to make sure that we don't get that negative sign. 10 times the, that'll be the sine of angle. And he is headed in what I'm calling the positive, so that's a positive number. Okay. All right, so, and then I'll apply it also for mass B in the plane. So I've still got 0 for him. He's equal to the mass of B in the plane, the momentum of B in the plane after the collision. So that'll be mB, speed of B in the plane. I don't know which way he's going, so I think he's going to go in positive, minus, because the formula says it's, initial minus final. Okay, minus the momentum in the plane of B, mB. That would be this piece right here. So that would be mB 8 times the sine of the angle. And he's pointed down in the negative, so he's a negative there. Okay. All right, so now I've got 2 unknowns already identified. I don't know this one, and I don't know this one. So now I've got 4 unknowns and still only 3 equations. Don't forget the coefficient of restitution. So here comes the coefficient. Now you have to apply the restitution in the normal direction only. So that'll be E equals. So it's the velocities after divided by the difference divided by the velocities before. So that would be afterwards I've got velocity of A in the normal. Which way do I think he's going? I thought he was going in the positive. Minus velocity of B in the normal after the collision, divided by, and now I reverse them. So I'm going to do B minus A on the bottom, and it'll be in the normal, and it's before the collision. Okay, so before the collision, B was equal to, let's see, this piece right here. But there's the velocity of that. That would be 8 times the cosine of the angle theta. And he is headed in the positive direction. And then I say minus, because it's the difference. The velocity of A is in the normal, is this piece right here. So that would be 10 cosine of theta. And he's in the negative direction. So that'd be right there. Okay. So now, how many unknowns? 1, 2, 3, 4. How many equations? 1, 2, 3, 4. So then you just do algebra and work it out. So that'll get you the velocities. I think that's all he wanted. Yeah. Okay, so that's how you do that one.